So today I'm going to show you how to construct a rotation. So as you can see here, we're going to rotate this triangle ABC 90 degrees counterclockwise about point P. So we're going to take this whole thing and just turn it 90 degrees around this point. Okay? So one of the first things you have to know about rotation is when it rotates, each of these points is going to remain the same distance away from point P no matter how far you rotate it. So for example, point C is this far away from point P. What I can do is I can use my compass and draw a little arc. And that's the path point C is going to take as it rotates around point P. But the question will be, how far do you go? When do you stop? And that's where we need this 90 degrees. So what I'm going to do is I'm going to connect point C with point P and draw a line or a line segment. All right. And what I need is for this line to rotate 90 degrees. So I need this to turn 90 degrees. And I know how to construct that. A 90-degree line can be constructed easily using a perpendicular bisector. So take that same distance, swing an arc there. Now I need to construct the perpendicular bisector of this little line segment right there. So make my arc a little bit bigger. From each end, I'm going to swing an arc, and it's going to go through the instructions, but that's okay. I already know what I'm supposed to be doing. But I've got my point P, I got my intersecting arcs. Now I can draw my line. Well, that's pretty good. There you go. This is perpendicular, so I know from here to here, this is a 90-degree rotation from here to here. And since I know C is supposed to follow this path, I know this right here will be my C prime. Now, to find the other 2 points, I could do exactly what I did before. Swing arcs for the path of each one, and then draw perpendicular lines, but there's actually a faster way. I don't actually have to recreate these 90-degree lines every single time because, well, first off, I know already the path of each point. For example, this point A, I know it's gonna go along this distance, along this path right here. But the other thing I know about rotating a figure is the size isn't gonna change. So in other words, I know this distance from A to C, this distance right there. Let's see if I can match it up. I know this distance from A to C is not gonna change. So if I can line that up with my compass, and then I can recreate it off of C prime. Ooh, I made that just long enough. Where the path intersects with that mark I just made, that's gonna be my A prime. Because the distance will be the same from C to A as it is from C prime to A prime, and that's also the path that's going to take. So I don't have to recreate the whole angle, I can just use that simple fact. All right, I'll do the exact same thing with point B. I'll draw out the path of point B. Let's see, my guess is going to end up over here somewhere. And I know from B to C, this distance is not going to change because, like we just said, when you rotate, the size of the figure isn't going to change. So from C to B, it's going to be over here somewhere. Where they intersect is B prime. So I know B prime is going to end up right there. Connect them up, and that will be my rotated image. Let's see. There you go. And then just do a quick double check. Is it rotated 90 degrees counterclockwise? It looks like the same thing. Yep. Is it going the right direction? Yep. Looks good. So our rotation is done.